Okay, everybody, I'm going to start a little bit early, and that's okay because I know that this is going to be recorded, so anything that you might miss, don't worry about it. Again, if you miss anything, don't worry. It's about 5 till, and my hunch is I might have a few people join me today, maybe not, but I'm going to go through today's class. Now, things have been a little bit discombobulated for a very simple reason. The first week of class started on a Thursday, so we kind of got X'd out of that, and then we had we were to have class on the 28th. Got blown out of the water on that because of a medical appointments that I had, and so then of course came Labor Day, which was the 4th. So we've been kind of discombobulated. And I did pre-records last week for you on the 30th, and then I think again on the 1st. But this is a live stream recording, and as you know, you don't have to be here if you're not. You're certainly welcome to. I did send out, I did post over in the announcements, I posted the link to the meeting, and I'm sure I'll have some of you join me. And again, if you, here's the link to the live stream. And some of you, if you don't get that chance, will be able to see the recording. So my hunch is you're all you've got stuff you're doing, or you've taken to heart the fact that this is recorded and is available for you. So this is the 6th of September, and I'm going to go ahead and we'll take a look here for just a moment at module number 2. Okay. And as I mentioned, Wednesday's live screencast that was recorded. And so we had the screencast, and we need to review the Nolan key. Then we're going to take a look at M&D chemicals if the time permits. And the M&D chemicals case is over there on pages 52 through 57. And what I want you to do is to find the left-hand solution and the right-hand solution if the processing time is increased 10% per product and the time available is -8%. Okay? And then I want you to upload the MD Chemicals paper there. Now, I want to just go over some things here very quickly, and I want to make sure that you take a look over in chapter 1. You should have been reading it and talking about the difference between problem solving and decision making. Okay, talking about how we do optimization, and there in the Nolan case, you were asked to the Nolan case is using the break-even point. That was over on Appendix 1.1 in the textbook. Pages 24 through basically 27, and using the goal seek, to find the break-even point. Now I posted the key, okay, and I made the key visible, all right, and we're going to take a look at it. And so I'm going to go over here into file. Now let me stop for a moment and tell you again how to navigate. The syllabus set, the modules, gives you what's going on with us on a chronological basis, okay? And again, if you come in late, don't get wigged out about it. We're good, all right? And then on the syllabus shows us what's due, okay? And the Nolan Plastics was due. You're going to see some of these. Let me go over to the settings, and I'm going to go to the student view because there's some stuff there you're going to see, and it will confuse you. So I'll go to the student view. There we go. Now, I'll go over here to the syllabus, and this, again, just some navigational steps so you can see what's going on. As I said, it's a little bit of a misnomer. This shows you what's due, and of course the 1st of September, Nolan Plastic was due, and then you have these exam items. Then on the 8th, PAR ink is due, as well as M&D chemicals, and we're going to talk about them for just a. We're going to look at Nolan plastics for just a moment, and so let's go over to the files section, okay? And you'll see as you scroll over here on the files section, you're going to find the key for Nolan. And I should have downloaded it instead. My apologies. While I'm thinking of it, I want to make sure that I mention, don't forget that we're going to have a ground-based class session Monday. As I said before, the 21st was before classes started on the 24th. That was August. August 28th, I had medical appointments, so I wasn't able to make it. And then Wednesdays and Fridays are virtual days anyway. Then the 4th of September was Labor Day. So we're going to have a physical class meeting on the 11th at 11 o'clock over there in BBC Lab, okay? So we'll be having, then we'll be in this pattern of a live, a physical class meeting, which I'll also record for those who can't or don't want to make it. It's a hybrid class, and then on Wednesdays, our virtual Wednesdays, I'll be streaming. Now we're going to open up the Nolan key. All right. If I don't want to keep wanting to do that, and I need to just learn to teach myself to download this. So we're going to download Nolan key. All right. And we were asked to use GoalSeek, okay, to obtain the fixed cost necessary to achieve break even, okay? And you'll notice that we did this on fixed cost, and the fixed cost had to be $8,000. Okay. Now you say, all right, well, how did we do that? Well, it's very simple. We're going to click on data, okay, and then we'll go over to click on data. Pardon me, and then you'll come over to what if analysis, and you're going to go to GoalSeek. And you're just going to click the set the cell and to find the fixed costs necessary to achieve break-even. Hi there, glad to have you here. And don't worry, Fred. I've been going for a while, but this is recorded, so anything you've missed these first few minutes, you can take a look at the recording. And so I did start a little bit early, but now that way, if I need to run a little bit longer than 50 minutes, I can do it. And this is this first thing, the fixed GoalSeek to obtain the fixed costs necessary to achieve break even. This is the Nolan Plastics case, and the key, which we're looking at, is now published over there. And typically, here's how I want the cases, you guys to do the cases. Try them, okay, and then I'll publish a key and we'll go over them. But you get credit just for trying them, all right? That's all. Just try and do something with them. It's a learning process, and I don't expect you to just do them perfectly, okay? But I do expect you to try. It's how I do with all of these labs. I like to let you take a shot at it and see how you do. And I think you learn more than when you see it corrected. So we're going to use GoalSeek to obtain the fixed costs necessary to achieve break even. Okay, so I clicked on the data tab, and then I clicked on what if analysis, then I clicked GoalSeek. So we're going to click right here. Okay, and said we want to get 800 we produce 800 units. Okay, so I want to achieve break even, and I want to set that fixed cost. All right, I want to set the cell here. Okay, so that we get the total profit, or like, I'm getting myself behind here. I want to set it here. Let me just wipe this out for a minute. Okay, that's my fault. I'm going to click on the goal seek, and I want to achieve break even. And I want to do that. I want to set that value to 0 because that's break even, total profit or loss, by changing the fixed cost, and we'll run it. So I clumped through that, and I apologize. I set the cell B18 to 0, so that was at break-even point, okay? And I wanted to do that by changing cell B3. And so I'm going to run the goal seek, and it's going to do its thing. And it'll say okay, and here we go. Now, this again requires a little bit of understanding, again, of the total cost equation. And the authors walk you through that process over there of finding break-even volume, okay, which is basically the break-even volume is the fixed cost divided by the contribution margin per unit. And the contribution margin per unit is the revenue per unit less the variable cost per unit, okay? And so that's how you get the break-even volume. And then we have the profit goal. So we use the goal seek. Now, if I click up here, you're going to see the scenario manager, the goal seek, and the goal seek says we work with one variable. Scenario manager, we work with multiple variables. Now, once you have Microsoft Office open, okay, Excel open, then you'll want to make sure that you have the solver. And the way that you do solver is you press on File, down to Options, you have Add-ins, and it will tell you those that are inactive and those that are active. And if the Analysis Tool Pack, if the solver add-in is inactive, press on it, press Go, and you're good. And then when you open up Data, you click the Data tab, you'll see solver up there. Okay, so that was the first thing. We're just using the goal seek, and the whole idea here is for us to work through this process, as the authors talk about, of defining, okay, an objective function, okay, and then working through the constraints, maximizing, subject to the certain constraints, maximization, minimization, and going from there. Now we've modeled that in the very first, kind of done a baby bit of it by saying, all right, my objective function is break even, 0 total profit, no profit or loss, and with the constraint in terms of the fixed cost of whatever that's going to be. So we found the constraint there, and we ended up with a production volume of 800. So we end up with the fixed cost, okay, that's $8,000. The variable per unit is $2, okay, and that of course is a cost that changes. Variable cost is a cost that changes with the level of production. So 2 times 800, okay, is 9,600. Our total revenue, we sold 12 of them, and there we are. So that's the break-even fixed cost. Now let's look at the break-even volume, okay? And the break-even volume, okay, is 1,000, and that is we're going to sell at a sales price of 5,000. All right, and here we're assuming we have fixed costs of 3,000. So let's click up here. We'll click on the what if analysis. We'll look at the goal seek. Okay, I'm going to set this cell to 0. Okay, and I set the cell, and I'm going to set it to 0 because I want to achieve. And by changing the production volume, and then we'll click OK, and there's our solution. And so in this case, we had fixed costs of 3,000. Okay, our variable costs were $2. Our selling price was $5 per unit. So we had a total cost of 5,000, and that total cost Here it is expressed in the formula. It's B3 plus 2 times B12. And the two obviously is the $2, and B12 is the production volume. And remember, the variable cost equals the number of units produced times the variable cost per unit. That plus fixed cost gives us a total cost, and when total cost when total cost less total revenue is 0, we're at break-even point. Okay, so the whole idea of this very first thing with Nolan was just to kind of get us a little bit comfortable with doing some of this thinking. Here's the profit goal, okay? And again, this key is published over in the files. And I can't, and I've had a few of you join again. Remember, this is recorded, so anything you might have missed when you came in a little bit late, if you needed to, you can go back and you can see it. And you could just, in fact, once I publish a video in YouTube, you can just find the minute mark and go right there. But nonetheless, this whole idea is to kind of get us thinking about the optimization process whereby we choose an objective function, okay, and then we choose then we select constraints, and then we perform the operation. And this is, and we're basically doing that here. We're just using GoalSeek, which is kind of a baby optimization tool, if you will. In this case, we're to use GoalSeek to obtain a selling price per unit necessary to achieve a total profit of $5,000, and the result is $12. Okay, so I'm going to click What If Analysis. Now I'm going to click on GoalSeek. Okay, and then I'm going to set the sale. Now this time I want a total profit of 5,000. So instead of breaking even, I have now a target value. And when we when we start working with Solver, you're going to find that we choose the objective function. And then with the objective function, we have one of 3 choices. Okay, we can minimize, maximize, or choose a target. Okay, and that of course is, you know, the full range. I want to get the most, the least, or I want to hit a 0 point or some target. Then we have the constraints, and then if we have constraints, we put what those constraints are into the dialog box on Solver. Solver is highly intuitive, very easy to use. Then we have to make a decision about the type of relationship between the variables. Now you're going to see when we get into Solver, there's a thing called LP simplex. LP is the acronym for Linear Programming Simplex, meaning we assume the most simplistic of all relationships between 2 variables, and that is an XY. Interest rates go up, housing sales go down. Okay, interest rates go down, housing sales go up. You remember this from micro, and I'm sure now you've formed the sign of the cross, eating garlic or whatever, because you're going, oh no. But basically, okay, if we assume there's a linear relationship, okay, then we can model it. And as you get over into chapter 2, the authors are going to walk you through all kinds of fun over on pages 36 and 37, for example, getting to graph objective functions. Now you can thank your lucky stars that it's me teaching this course, not my predecessor, because my predecessor loved to put you through about a ton of graph paper building linear equations to come up with the solution, which frankly I think is wonderful to see it in the textbook, and I think it's very awesome, etc. However, as a manager and a business person and a decision maker, you need to see, you need answers. You don't need to go through an exercise in linear algebra. So the tool is there, Solver's there. The key is, do you know what to put into the formula? Okay, and this is like this. Put it like this: you guys are a chef. You're going to be given a kitchen. in a restaurant. If you know the recipes and you know how to use the equipment, why then would I make you go learn how to why would I have you go manufacture equipment? That's insane. So we're going to learn how to use the tool. Well, we are going to use GoalSeek to obtain a selling price per unit necessary to achieve a profit of $5,000. I want to set my goal. Okay. And I want that total profit or loss. I want it to be 5. Okay. And I'm going to change it, and I'm going to change it. The change in cell will be the selling price per unit. And I'll run it. And there's my solution. Okay. And I know that I'm going to have to sell these, okay, at $12 in order if the fixed price per unit. So let's look at this at fixed cost. To get a total profit of $5,000, the fixed cost is $3,000. The variable cost per unit, okay, is $2. We're going to make 800 of them. So the total cost is going to be 3,000 plus 2 times 800, which is 4,600 bucks. The total revenue is $9,600, and so the total profit or loss is $5,000. And so that and that's Nolan, and that's Nolan. Now, would I expected you to have turned in something perfectly like this? No, not really. I would expect you would try and you might get one of them. And this is no insult. It's just simply, this is just something that once you work through it. Now, as we get later on in the course, my expectations will change a little bit because you'll have been used to using Solver. You'll understand the process, and you understand that what I do with these cases is usually I take a chapter and condense it down to about 50 minutes when you might spend hours trying to read through all the chapters. So I have you go through I have you go through the exams, okay, and to get out some of the key points. But you know, the practicalities of it are a whole different matter. And you say, well, what do you mean? Well, let's talk about this for just a moment, okay? There's some stuff I need to know. First of all, I need to know, for example, here, what indeed is my fixed cost? Number 2, I need to know what is my variable cost per unit. If I don't know those 2, okay, then I can't know what my total cost is. So when you see these cases and you see us and you see us build them, all right, you're going to be, you need to remember that this is almost like a summary or a pro forma, if you will, and that you've gotten data on costs and price and all that stuff. These are data, and so you're getting a summary of them. Now, the whole idea here is, is also to let us look at possible futures and to say, okay, and to understand that decisions that we make run along a continuum. They're not black or white or good or bad. They run along a continuum. And what I mean is decisions that we make can be really, really good, really, really bad, or kind of somewhere there in a range. So this course is as much about letting you see your options or an approach to do that, as opposed to just, well, here's how I use a piece of software. That's why in the first chapter, the authors really put a heavy, heavy, heavy emphasis upon the difference between decision-making and problem-solving, okay? Big difference, and they walk you through that there in chapter 1. So that's Nolan, okay? And that's the key, and it is indeed published over there. I've got it published in the files, and I'm going to close it off for a second, okay? And we're going to go back up here, and we're going to talk about some of the other assignments coming up here. This is over in the syllabus, all right? And you'll see that on the 8th, you have 2 cases due, okay? And Friday, of course, is the 8th. And here are the instructions. And I refer you to the pages, okay? And I ask you, okay, the time available is not yours. Now I just walk you through what will be the change in profit now. Okay, you'll say, where do I find the files for this? Okay, well, I'm going to come down here. Okay, and you're going to see this thing called MS13 web files. All right. Now, in your book, and I want to clear up maybe some confusion you may have experienced, you're going to see the authors referring to a thing called lingo. Okay, lingo is a baby solver that they have set up at the course website. If I chose to have you do that, it's another $150. So I think you'd rather slog it through Excel with me than spend another $150 and go into lingo and try to deal with it. And you end up in lingo writing a lot of code that you don't have to do with Excel. Okay, and I'm going to tell you right here, right now, if you work for a company so big that Excel can't handle the number of cases in an optimization study, you're probably buying a commercial product, and you probably have a staff of people, unless you've got a master's of science in management science or operations research. Because as you're going to see, as these things get more and more complex, there's a limit with the computational limits that Excel can do, and that's when you have to move into some commercial products. But if you understand the process and you understand what you're trying to do, that's the most important thing. And I'm going to give a commercial. When I'm teaching MIS semester because Ms. Turnage, of course, left, and one of the first exercises, maybe you're taking it with us, taking it with me, is I had everybody go in and go to all the job sites like Monster and look for the qualifications that employers are after. And employers are after two things that keep cropping up. They want you to have spreadsheet experience, preferably Excel, and they want you to at least understand how to work with Access and databases. Okay, and I can tell you then, if you come out and you understand those, and you really understand, then you take this course, and you understand how we try to build models. Remember that the text talks about those types of models that we build: a mathematical model, okay, or an iconic model, okay, like a physical model, or we try to build a spreadsheet or an information flow diagram. You're so much ahead of the curve, it's not even funny. Okay, and I can't tell you that enough. And I can assure you, if you want to know where the jobs really are, and I encourage you, and this is again a commercial, for some of you, you might be smart as you start looking for jobs, if you're not already, or internships, to out there in the field of logistics. The reason being that, I don't care how much stuff you sell online, okay, you got to get it delivered. And so there's this whole back office of companies and folks that work in logistics whose skills are highly valued, and there's not a single one that doesn't have the brains to work with that stuff. I will never forget, when I taught the production course, I used to take students over to Eaton. They're in Shawnee, and Eaton makes brake pads and brake liners for a big, I think they're a company now was bought out by a Chinese conglomerate. I took 25 students over, and we took a tour of their plant. At the end of the tour, the human resources lady begged anybody who wanted to put in an application, okay? And because they need folks who have the kind of skill sets you're going to have when you leave. And only one person out of that, one student out of the whole 25 applied. He got a job with them. He started working in their traffic department. They paid for his MBA at OU, okay? They sent him to over to Vietnam, then back again over to China. Okay. Then a headhunter firm heard about him, lured him from there, and he's working for an outfit in Kansas City now. And I would bet you he's making he's in the low six figures. Okay, they're desperate for people because, you know, and just think about also the people like Amazon who are talking about having these autonomous delivery vehicles, and those are logistical issues. So I'm putting in a plug, and there are going to be some great opportunities out there for people. And as you go through, you're going to see that this whole idea of optimization is a tool that's applicable to every field in management. It's just every single way. And you're going to say, sound like a broken record, Dr. Harmon, you're going to see it over and over and over. Well, let's look for just a moment, and here are the MIS web files, and I'm over in the files section, okay? And I'm going to download those. It's a zip file, okay? And I'm going to pop over chapter 2, and you see there are the lingo files. Ignore them. Here are the Excel files, and here's the file for M&D. These are the skeleton files for M&D and the skeleton file for PAR. All right, and so you'll need to take them, and what I would do is I would download them, okay, and then I would go back over here to the syllabus. It's kind of it's a misnomer, but it's kind of a misnomer, and to make sure that I'm on top of what's due, all right, I would let's take PAR Inc. for a moment. I would copy, okay, the directions. I'd throw it on a notepad, okay, and I need to copy it first, don't I? That's brilliant. And then boom, and then I would open up that file. Okay, let's take the MD for a moment. Is that PAR that I did? Yeah, let's open PAR, and I'm gonna open PAR up. Okay, and this is so that I know what I need to be doing, and I'm gonna click OK. I'm gonna enable this. All right, and I'm gonna insert a text box, and I'm going to put the instructions in there, okay, so that I know what to do, okay, and I don't get lost. Now, I give you the text reference, and that's pages 87 through 91 in the text, okay, and the left-hand side and the right-hand side, that's the minimization equation, and the left-hand side is going to be the constraints. The right-hand side is going to be the objective function, and you'll see that, and you'll figure that out as you look through chapter 2. Okay. Now I have this set up for you. All right, and I'm going to click on data, and I'll make sure you have solver, okay? And I'll just show you real quickly here since I've spoken about it, all right? Now, here's the solver dialog box, all right? And it's very, very simple. And you're going to get so tired of hearing this at the end of the semester, you'll go, please shut up. Here's the way it works. Here's the objective. Now, let me stop for a moment. The authors who probably got paid by the page, they can make this thing 1,000 pages as textbook. It's the gold standard in the textbooks. In other words, it's written in such a way that a normal human being can understand it, okay? And so it's a good textbook, but the authors go through all of the mathematical proofs, okay, so that you can rest assured that what they're saying is right, and so the rest of us can, okay? And basically, they're going to want it, but, you know, which is fine. But that's why I do these lectures. If you could just sit and do this by yourself, I just turn you loose. But you got to understand it. This is par. They have some kind of they're making clothes or something. I forget what they're doing. But if you look up here, they've got some constraints that they're working with. Okay, and then they have some decision variables. So let's leave. I'm gonna leave the solver parameters open there for just a minute so you can see them. Okay, and remember, don't forget, paste in what you're supposed to do. And we have the objective function, and that's over here in B18, and that is we want to maximize the total profits. How do I know? I clicked maximize. I set my objective function, that is the answer, or what I want, and I can maximize, minimize, or hit a target value. That's why you've heard me say over and over and over, decision making, the result of decision making, and that's what you get paid for, is like a continuum. Stuff can go really bad, really good, or most of the time just somewhere kind of in there. All right. And the bottom line is that's what this is showing. Okay. Now, by changing the variable cells, these are the variable cells, and that's B16 through C16. And so we'll look at B16 through C16, and those are the bags produced. They produce two types, that is, they make bags, I'm sorry. They produce bags. They make one that's a standard and then one that's a deluxe. So they've got a plain Jane model, if you will, or plain John model, and then they've got the deluxe, okay? And so they're trying to figure out how many of each of these do we produce. This is what we call a load balancing problem, okay? Because we need to know, because we operate under certain constraints. So what constraints are you operating under? Well, you're operating under these standards in terms of production time available. And here are the operations: cutting and dyeing, sewing, finishing, inspection, and packaging. Okay, and then there's the profit amount per bag. So what you're trying to do is maximize, okay, B18, which is the total profit, okay, and you've got these cells, the bags produced in B16. So you need to know how many bags can I produce to get the maximum total, total profit. Now you'll come down here and you'll see it says subject to the constraints. These are my resource constraints. It's usually going to be people, money, and time. Okay. We're going to see some problems where a constraint, where we're working with network problems like an airline or a delivery service, where a key constraint is time or distance. Well, we've got time here, but distance is another thing that can come into play. So, when you look at this, you say, okay, and then you come down to make unconstrained variables non-negative, okay? And what this means is we can't have any negative variables. We can't. Now, we're going to see some models where we can, but typically we're not. And then you see select a solving method, and you see the simplex MP, okay? And the LP. The simplex LP is simplex linear programming. Linear meaning, okay, that there is a linear relationship, an X-Y relationship, a correlation, if you will, between the variables. Okay? And that's why the authors beat you over the head senselessly doing linear algebra. I think because they believe it will help you go to heaven, or maybe if they beat you up enough, it will make you frightened of your employer. I don't know, okay? But let me tell you what, my friends, I've done the linear algebra enough times. After a while, it just feel like a beating. And you can make easy mistakes so easy. You've got the software here. Now you say, here's the thing. Would I rather you understand what simplex is than to do a bunch of graphs? Yes. Okay?
Right.
Because you're not paid to be grunts that do graphs. you're paid to be decision makers, okay? And so you've got to understand the nature of the problem, okay? And so the nature of this problem is it's linear in nature, okay? Why? Because you've got total costs, variable, you've got fixed costs, you've got variable costs, you've got a profit, okay? You've got production decisions that you want to make, and that's what they're showing. Now, when they use the term LHS and RHS, okay, if you look down here in cells 20A over to D24, you'll see these are the constraints. And the constraints on the left-hand side is and they look this in terms of hours used, okay, versus hours available. The left-hand side is what we actually use or need to use. The right-hand side is what we've got to do with it and what we've got to accomplish the task. And if you look up here, you'll see, okay, the time available for cutting and dyeing and how much time you've got for standard versus deluxe, sewing, finishing, and then inspection, okay? And that gives you the profit per bag. And so what I ask you to do is to come in, okay, and change some of those, okay, and tell me what the change in profit will be, okay? And so, you know, you say, okay, Dr. Harmon, you know, is this right? Yes. Okay, this is what I'm wanting you to do. And now, it's not just putting the numbers in there like a monkey. It's asking yourself, okay, why would I be putting in these particular set of numbers? Okay, and what might drive that? And let's look at this for just a moment, okay? The standard, I get compute LHS and RHS where the standard cutting and dyeing is 0.77, okay? So the standard up here, this assumes a 10% jump in cutting and dyeing, okay? And let's say you have to absorb that. Well, how's that going to change your bags? How's that going to change the bags produced? And ultimately, how's that going to change the profit? Okay, and then on inspection, and then sewing 0.5, 0.5, okay, on cutting and dyeing, and then on inspection packaging, we take that on the equals 0.14. And then I give you the time available, and I take 95% of the original values. So you're rolling along, you've got this nice model built for your bags, and suddenly corporate calls and says, hey, we have to cut your budget by 5% in terms of the time available. So these are changing, these reflect changing conditions in the company. And so you want to see, well, what will it look like if we do this? And you remember, if you've had a class with me, remember I took the Q, and I made those quadrants at the top were the states of nature or conditions. On the left-hand side were alternatives or alternative choices or options. And then I carved that up, and I said known versus unknown, known versus unknown, and we talked about which of these quadrants is the riskiest. And obviously, the riskiest quadrant is where the problem is unknown and the solution is unknown. And I said, it's your job as a manager to nudge that line over just a little bit so we have a little bit more knowledge about how to deal with problems. Well, optimization is designed, okay, to not give us the answer, okay, but to give us a feasible set of answers or probable outcomes, okay, and within an expected range. And so that's what we're going to be doing there. So when you do the paring, you know, download the file, and then you want to have the text, and you'll want to go ahead and make those changes and tell me what changes in terms of the profit. And after the thing is due, I'll go ahead and then I'll go through this. I'll go through the solution with you. Okay. Now, let me remind everybody, and I started this at the start, and just so next Monday we will come face to face for the first time. You remember the 21st of August, that was before classes started, so we didn't meet that Monday. 28th, I had doctor's appointments, so we didn't meet that Monday. This Monday, the 4th, was Labor Day, so we didn't meet, but we will start having our physical meetings on Monday, the 11th, okay, which would be next Monday at 11, and I'll be over in the lab, okay, the big lab, and we'll go through this. Now, I'm going to record those sessions. As I've said, I'm treating this like a hybrid course, and thank you, the 5 of you who are here. God bless. I'm glad you're here, and you can re-listen to the first part you missed, and everybody else can listen in, and I'll record this and save it as I've been doing. Now, let me diminish this down for just a minute, and let's go back up, and I'll diminish this, and let's go back over to the syllabus section, okay? And you also had M&D chemicals, okay? And that's to be uploaded. Now I'm going to go back here into this file, and I'm going to open up M&D. Okay. So I'll close. Let's see. Let me close PAR off here for just a minute. And I'm going to close that off for just. Let me get that up here. Oh, gotta close that. Now I can close. Here's M&D, and I'll enable the editing, and then I'm going to click Data, and I'll come over to Solver, okay? And here we go again. Now you say, all right, are you saying to do the same routine? We're going to go in, okay, and you're going to click on this thing so you get the directions, okay, and I ask you to do that. Let me find the, they give me some directions for this. And what did I want you to do with their examples? Shoot myself if I didn't give you some directions. I didn't give you any directions. Okay. I'll put some directions in there for you. Like a touch, I didn't. Let me click in the modules for just a minute. Let's see if I told you what to do. I might have done that in the modules. So if you don't see it in the files section, if you don't see it in the syllabus where it has all those assignments listed in order, you might want to check the modules. So let's do this. Okay, and yeah, M&D chemicals, pages 52 through 57, find the LHS and the RHS if the processing time goes up 10% per product and the time available goes down by 8%. So those are the instructions there. So when you go, you're either going to find the instructions in the syllabus, which is, as I said before, it's kind of a misnomer. That's somebody calling me, probably a robocall. If it's something, leave a message. But the bottom line is this. You'll either find it here in this listing of stuff that's due, okay, and if you don't go over to the module section, the syllabus shows you the stuff that's due, okay? And the modules is chronology. In other words, week by week by week, okay? So you'll find, so for the M&D chemicals, okay, that is over in pages 52 through 57. Over, and this is in the Anderson text. That's the Introduction to Management Science, okay? And you want to find the left-hand side and the right-hand side if the processing time is plus 10% per product and time available is minus 8%. So here's M&D, okay? and you'll want to make those adjustments, okay? And take that and paste it in. Take those instructions and paste them in so you know what you're doing. You see, even I'm scrambling around with it, and I developed the course and I helped edit the book a long time ago. But make a long story short, you'll have that. Now, you may have to add solver to your machine. And again, I would do this. Click File, Options, Add-ins. And if solver is down here in the inactive applications, click it, then click Go, and it will show up in the toolbar on the data. Once you click the data tab. Well, folks, listen. It's 11:44. I did start early. This session is recorded, so if you didn't miss anything, if you came in a little bit late, and I do appreciate it. And let me pop on here and see. I see Bo, glad to see you. I see Jan, Josie, glad to see you here. Conley, I see Nick, and I see Suzanne. Glad to see you here. Thank you so much, folks, and for coming. And again, once I've finished recording this, I'm going to stop the recording. Then once I finish converting it, it'll be over on YouTube for you to see. Okay, and then then you'll have Friday. That stuff's all due Friday, so you can do your work Friday, and that's the virtual Friday part. And then don't forget, next Monday we will meet physically. Okay, and we'll go over and we'll go through what we're going to do for that day. And then Wednesdays and Fridays will continue to be virtual days. But we just haven't had a physical class yet because of all these circumstances. So I thank you, appreciate it, and I will see you folks next week. So I'm going to stop the share and then stop the recording. Before I do though, I've got several of you on here, and let me unmute everybody. Anybody have a question I could help you with? Bo, any questions? Conley?
No, I'm good.
Okay. Jan? Questions? Josie? Okay. Nick? And Suzanne, any questions? Okay. All right, folks. Then send me an email. And one thing before I go, and it's this. I have been sending people emails with my virtual office hours. Now, let me tell you how that works. You click the link, you come over, and I have a virtual room. I get an alert that you've come in. I can turn on the video. You can see me. You can hear me. If I need to walk you through something or you have a question, I can help you. Emails are fine. But I do have those office hours there if you need the help. So I'm very happy to see it. Now, yesterday I posted 5 office hours. I don't know how many I've got posted today, like 3 or 4. And so I'm here to help you. And I can do the same thing in that virtual office I could do if I'm sitting in the office with you. Okay. The only thing is you don't get to look at all the cool pictures of me, like with Billy Graham, the Pope, and stuff like that. That I know is a bummer. But if you have a question or problem, you can come in. I can access, data if you're an advisee or whatever, or I can try to help you with a problem or a question. You can see me, you can hear me. I can share my desk, talk with you. So avail yourself of that if you feel like you need to do so when I have a published office hours. Okay. And it just gives me the ability to help you out even that much more. All right, well, let me get off here, folks. It's 11:50. Thank you for the time, and I'll get this thing converted, then recorded, and posted to YouTube. Have a good one, and I'll see you next Monday. I'll see you Monday.
What's up?